All right, children. So we finished exercise 11.3. This is exercise 11.4. Example 8. Find the height of a cuboid whose volume is 275 centimeter cube and base area is 25 centimeter square. So volume of cuboid is given to be 275 centimeter cube. But what's the formula to find the volume? Length into breadth into height is equal to
L into B.
Correct. L into B into H is equal to 275. And now what is L into B? It's the base area. L into B is the area of the base. What's the area of the base of a cuboid? Cuboid. This is the base. This is the base. What's the base area? Length into breadth, right? The base area is L into B. Yeah, the base area is L into B. L into B is base area. So you can, if you want, write area into height is equal to 275, or you can write base area also. Base area into height. So H is equal, sorry, not H. Yeah, so 25 into H is equal to 275. So H is equal to, or the height of the cuboid is equal to 275 divided by 25, which is equal to 11 centimeters. Please write down.
Excuse me, ma'am.
Yeah, good evening, Raja.
Good evening, ma'am. Sorry, ma'am. Sorry for the delay, ma'am. My mom went out of station, so now only she saw the message and told me.
Okay, fine. But I don't think you joined the last class also, right?
Yes, yes, ma'am.
Class
No.
also, I did not find you during the meeting.
Yes, ma'am.
All right, fine, Raja.
Yes, ma'am. Sorry, ma'am.
I can't say it's okay, but you have some reason, so I just have to accept it. Yeah, see to that you don't miss the messages.
Yes, ma'am. My mom actually went out of station. That's why only I'm not having the phone.
Don't have the phone to see the messages. Okay.
Yes, ma'am.
Okay, I understand. Okay. Yes, children, please write down the answer. Volume of cuboid is 275. You can mention this. L into B into H is equal to 275. L into B is base area. L into B is base area. LBH is equal to 275. L into B is base area. Into H is 275. Base area is given 25. So 25 into H is 275. H is 275 by 25, which is 11 centimeters. So the height of the cuboid is 11 centimeters.
Completed, ma'am.
Completed, ma'am.
All right. A go down is in the form of a cuboid. A go down, a place where goods are stored. A go down is in the form of a cuboid. It's a room. A go down is nothing but a shed or a room. A go down is in the form, it's normally in the basement area, meaning below the ground floor. Underground, we say, no, go down underground. It need not be underground. It can also be on the ground floor. Basically, a go down is a room where things are stored. So go down is in the form of a cuboid of measures 60 meters by 40 meters by 30 meters. How many cuboidal boxes? So this is a room. How many cuboidal boxes can be stored in it if the volume of one box is 0.8 meter cube? So the number of boxes that can be stored will be equal to the volume of the go down by the volume of one box. It will be the volume of the go down by the volume of one box. Okay, so see it here. You can see the question and the answer here. Number of boxes is equal to volume of the go down, that is the volume of the room, by the volume of one box. How do we find the volume of the room? L into B into H. Volume is L into B into H. So 60 into 40 into 30. 60 L into B into H. L into B into H. Volume of the go down is L into B into H. 60 into 40 into 30. And the volume will be in meter cubed because all the values are in meters. 60 meters, 40 meters, 30 meters. So the answer will be in meter cubed. The volume of one box you don't have to find. It's given directly. The volume of one box is given 0.8 meter cubed. Is the volume. It's not the length or the breadth or the height. It's the volume of one box. We don't know the length or the breadth or the height of that box. Its volume is directly given 0.8 meter cube. So directly write. Now don't wonder in the denominator why we have not done L into B into H. It's a cuboidal box. Why no L into B into H? Because we have not given the length and breadth, or we are not given the dimensions of the small box.
Good evening, ma'am.
Good evening, Madhumita.
Ma'am, I joined late because I had Hindi tuition and I just came back, ma'am.
All right, Madhumita.
Yes, ma'am.
So the volume is given straight away. The volume is given straight away. So substitute that value 0.8. Now, y into 10? Why we have done this is to get rid of the decimal point. What is this? What is this? Just to get rid of the decimal point. 0.8, no? We want to get rid of this decimal point. So we multiply the numerator and denominator by 10. We multiply, see it ends here. The formula substitution ends here. This is the volume of the go down L into B into H, and this is the volume of one box. We have substituted. Now what is this into 10 divided by 10? So we do this to get rid of the decimal point. We need to shift this here. So we'll multiply the numerator and denominator by 10. So that gives us 60 into 40 into 30. This into 10 divided by 0.8 into 10 is 8. See, in the numerator, we have written the 10 as it is. We did not multiply. In the denominator, 0.8 into 10 is 8. Is 8. 0.8 into 10 is 8. On simplifying this, we get 90,000. So 90,000 cuboidal boxes. 90,000 cuboidal boxes can be stored in the go down. Please write down. Is it over, children?
Yes, ma'am.
Okay, so the number of boxes is volume of the go down, volume of that room by volume of one box. All of you?
Almost, ma'am. 1 minute, please.
I'm writing the final answer.
Yeah.
Finished.
Yeah.
Completed, ma'am.
Good.
Completed, ma'am.
All right. I think all of us are finished. A rectangular paper of width 14 centimeters. So you can see it here. You can see the rectangular paper here. A rectangular paper of width 14 centimeters. So the length is not given. Length is not known. Width 14 centimeters is rolled along its width. See, it's rolled along its width. You can see the next figure. It's rolled along. That is this width and this width. They are brought together. It's rolled along its width. That means this width and this width, they're brought together by rolling. You can see the figure here. It's rolled along its width. And a cylinder of radius 20 centimeters is formed. On doing so, a cylinder of radius 20 centimeters, not diameter, radius 20 centimeters is formed. Find the volume of the cylinder. Find the volume of the cylinder. So now the cylinder will be open at both the ends because it's made by rolling a paper. So you can see from one circular end, you can see through the other circular end. Neither the bottom of the cylinder is covered nor the top of the cylinder is covered. Both the circular ends are open. That's just for your information. Okay. So what is that? We have a rectangular piece of paper of width 14 centimeters. We roll this also 14. So we roll it, we bring this one and this one together, the opposite sides together. So we roll it and we get a cylinder of height 14 centimeters. We get a cylinder of height 14 centimeters. And the radius of the cylinder formed is 20 centimeters. Find the volume of the cylinder. What's the formula to find the volume of a cylinder? What is the formula to find the volume of a cylinder? Have we discussed? Okay, so volume of cylinder is equal to pi r square h. Volume of cylinder is equal to pi r square h. So pi, the value of pi is 22/7 into r square, radius 20 into 20 into h 14. So simplify this and you will get the answer in centimeter cubed. Pi r square h. I would like to tell you one thing, children. Complete this, I'll tell you.
Completed writing, ma'am.
All right. All right.
Completed, ma'am.
Fine. So volume of cylinder is equal to pi r square h. Now, I said I just want to share something else. Understand here. What did we understand here? We said LBH LBH is the volume of a cuboid. And what you see here is the area of the base, area of base into height. So volume is area of base into height. See, here volume is base area into height or area of base into height. I wrote base area because it's given here base area or area of base. Both mean the same. I'm writing it again for you. See here, L into B into H is the formula to find the volume of a cuboid. In this, L into B is nothing but the area of the base or base area. So base area into height is the volume of a cuboid. Similar. Like a cuboid, a cylinder also has a uniform cross section. So what is meant by this uniform cross section? We'll see that next year in standard 9. For now, you just take it like that. Like, so, okay, I can. Now, if I say that a cuboid is formed by placing many identical rectangles, by stacking many identical rectangles, do we understand that? So you have many, okay, so you have many A4 sheets with you. Okay, you have many A4 sheets. Each A4 sheet is a rectangular piece of paper. You have many, say 100 A4 sheets with you. Each sheet is a rectangle and all the 100 sheets are identical rectangles. If you stack these sheets one over the other, the solid obtained is a cuboid. So now in the shop, when you buy a bundle of A4 sheets, in the stationery shop, from the stationery shop, when you buy a bundle of A4 sheets, the bundle is a cuboid, while each sheet is a rectangle. So we say that the cross section of a cuboid is a rectangle. The cross section of a cuboid is a rectangle because when we arrange identical rectangles, when we stack up identical rectangles, stacking meaning arranging one over the other. So when you stack up identical rectangles, the solid obtained is a cuboid. So the cross section of a cuboid is a rectangle. When many identical rectangles are stacked up, they are placed one over the other, they are arranged to any height, the solid obtained is a cuboid. Rectangle is a plane figure. When you arrange the rectangles one over the other, not rectangles of different dimensions, okay, identical rectangles. So when identical rectangles, where rectangle is a plane figure, when you stack them up, you get a solid, which is a cuboid. So area of base into height, area of the rectangular base into height is the volume. So basically area into height is volume. Area of the rectangle is L into B. When you multiply that by height, you will get the volume of the cuboid. Similarly, a cylinder is a solid obtained by stacking up identical circles. Circles are plane figures. Circles are plane figures. You have many identical circles of radius 5 or of radius 20 centimeters. You have many identical circles of radius 20 centimeters. You stack the circles, meaning you place the circles one over the other to a height of 14 centimeters till it reaches a height of 14 centimeters. Then the solid obtained will be exactly the cylinder. You have many circles of radius 20 centimeters. There are many. You stack them. You place the circles one over the other, one over the other. You place it like that till the height of the stack becomes 14 centimeters. So the solid obtained by stacking circles like this is a cylinder. So we say that the uniform cross section of a cylinder is a circle. The uniform cross section of a cylinder is a circle. Of a cuboid is a rectangle. Okay. So now the cross section, the area of the cross section is the area of the circle. So volume of cylinder is area of base or the area of the uniform cross section. Area of the base of the area of the uniform cross section. The uniform cross section is a circle. So area of circle into height. What's the area of a circle? Pi r square into height. So pi r square h is the formula to find the volume of a cylinder. Pi r square, where pi r square is the area of a circle. Area of a circle into height. Area into height is volume. Is it somewhat understood, children?
Yes, ma'am.
All right, so that's how we get this formula pi r square h, where pi r square is the area of the circle into the height of the cylinder. Area of the base is a circle, like LBH. Area of the base, L into B, into height. Area of the base into height. So here, area of the base is the area of a circle. Area of the base, circle, into height is volume of cylinder. Is it over, children? Finish right?
Yes, ma'am, completed.
All right. Look at this one. A rectangular piece of paper. A rectangular piece of paper, 11 centimeters by 4 centimeters, is folded without overlapping. Similar situation. Okay. It's folded without overlapping to make a cylinder of height 4 centimeters. To make a cylinder of height 4 centimeters. So using a rectangular piece of paper. Danya, did you attend last class, Danya? Danya? What happened? No response?
Ma'am?
Yeah, Danya, throughout last class.
Network issues, ma'am. No, ma'am, I didn't listen to last class, but I make use of that meeting recording, ma'am.
Okay, because throughout the class your call was on hold. Well, I did not put you on hold.
Because certain network issues, ma'am.
Okay, fine. Just
Tried to connect, ma'am, but I could not, ma'am.
Okay, fine. So a rectangular piece of paper, 11 centimeters. By 4 centimeters is folded without overlapping to make a cylinder of height 4 centimeters. So to make a cylinder of height 4 centimeters. Find the volume of the cylinder. Now, what are the two values you need to find the volume of a cylinder? What are the two values you need to find the volume of a cylinder? Let me show you the earlier answer. What are the two values you need? What is the formula?
Ma'am, the formula is pi r square h, ma'am.
What is the value? What is the value of pi?
22 by 7, ma'am.
22 by 7.
Pi is 22 by 7. R and H should be given to us, right?
Yes, ma'am.
Yes, ma'am.
You should be given the value of R and value of H. We cannot take some value for R and H. So R and H should be given. Look at this question. What is given to you? What is known to you to find the volume of the cylinder? H is known.
Ma'am.
Correct. The height is given. The height is known, 4 centimeters. pi is 22 by 7. See, the formula is pi r square h. The formula is pi r square h. You know pi is 22 by 7 and the value of h is 4. Now, how to find the volume? You don't know r. R you don't know. Then how to find volume? So the first thing is to find the radius. Volume formula is pi r square h. Pi, the value is 22 by 7. H is given 4 centimeters. R square, R is not known. So you should first find R and then find volume. How to find R? Now, will you agree if I say that the length of the rectangle, the length 11 centimeters, the length of the rectangle, what happens to this length of the rectangle in the cylinder? It becomes a circle. It's turned like this. The
Yes,
11
ma'am. When we fold it, it gets a circle.
Yeah, this breadth becomes the height. The breadth becomes the height. The length is turned like this to form a circle. So this full thing is 11 centimeters. Agree? See, this is 11 centimeters. It becomes a circle. It becomes
Ma'am, it becomes a circumference.
circumference of the circle. The length of the rectangle becomes like this. It goes like this. It goes round like this 11 centimeters. So it becomes the perimeter of the circle. So that means 2 pi r is equal to 11. Why 2 pi? What is 11? Length is 11. Length of the rectangle is 11. For the circle, 2 pi r is 11. So 2 into 22 by 7 into r is equal to 11. Using this, you can find the value of r. Once you find the value of r, use it here in the formula to find the volume of the cylinder. You can see the answer here. Please go through the answer. So we should first find r and then find volume. First, we should find r because without r, how to find? Use the formula pi r squared. So how to find r? You can see here. You can see here. Length of the paper becomes the circular base of the cylinder. Correct? Have I written it correctly? The length of the paper.
Yes.
Yeah, the length of the paper. Or I should write length of the rectangular paper. Okay, length of the rectangular paper becomes the circular base of the cylinder. So the length of the paper is L. It becomes a circle. It becomes like this. It goes like this. This one is 11. Area is not 11. This length is 11. This length is 11. That means 2 pi r is 11. 2 pi r is 11. 2 into 22 by 7 to r is 11. R is equal to 11. R is equal to 11. 22 by 7 becomes 7 by 22. 2 by 1 becomes 1 by 2 on the other side. When you transpose, they become reciprocals. When you transpose, they become reciprocals. And 11 ones are 11 twos are, so 7 by 4. R is equal to 7 by 4. Now the volume of the cylinder is 22 by 7. R squared H. Oh, I think 7 by 22 is wrong. I'll just check this children. One second. What have I written? Just a minute. Let's calculate now. So what will happen here? 7 cancels. 11s are, and this is 2s are, 4 and 4 cancels. So what do we get, children? 77, right? 77 by 2. 77 by 2 this is. Which is 38.5 centimeter cube. While typing, I made a mistake. So 77 by 2, which is 38.5 centimeter cube. All right.
Completed, ma'am.
All right. Over, children, all of you.
Completed, ma'am.
All right.
Completed, ma'am.
Fine.
Completed.
Yeah. You can just include whatever I have, annotated. All right, children. Given a cylindrical tank, okay, given a cylindrical tank, in which situation will you find surface area and in which situation volume? So if you're doing something with the surfaces, the curved surface, the two circles on the top and bottom, a cylinder has one curved surface area and there is the area of the circle on the top and bottom. If you're going to paint up, if you have to paint, then it is surface area. But if you're going to pour some liquid into the cylinder, then it is volume. If it is about the inner space inside, how much it can hold, then it's volume. If you're going to paint the surfaces, then it's curved surface area or the total surface area. So see the first one, to find how much it can hold. What will you do? Volume or surface area? Volume. Number of cement bags required to plaster it?
Surface area.
Surface area. Because the cement bags, you will not pour it inside the cylinder. You will not pour it, you'll rub it on the surfaces. You will rub the cement on the curved surface area, the top and bottom. You will not pour the cement bags or you will not pour the cement. You will not empty the cement bags into the cylinder. So it's surface area. To find the number of smaller tanks, that can be filled with water from it. Volume. Water is inside only, so it's the volume. If it's about some liquid which has to be stored in the container, it is volume. If it's about painting the surfaces, it is the area. Painting, plastering. See, that cement bag is for plastering. Painting, plastering, whitewashing, all this is area. So I think this you can just make a note in your textbook. You can just write 1 ABC. You can mark this in your textbook. Let's see the next one. Diameter of cylinder A is 7 centimeters. And the height is 14 centimeters. So you can see the figure there. Cylinder A, you can see the figure. Diameter 7, height 14. Diameter of cylinder B is 14 and the height is 7. without doing any calculations, can you suggest whose volume is greater? Verify it by finding the volume of both the cylinders. Check whether the cylinder with greater volume also has greater surface area. So we have to find the volumes. We have to find the volumes and the surface area. You can see it. Check whether the cylinder with greater volume also has greater surface area. So we have to find the volumes of the two cylinders and also the surface area of the two cylinders. Now see, nothing is mentioned. It's not mentioned if it is open or closed. Diameter of cylinder A, diameter of cylinder B. Height is given. And the word mentioned is surface area. It's not given TSA or, total surface area or curved. What's the formula to find the TSA?
Ma'am, 2LB plus BH plus HL, ma'am.
Darling, it is not cuboid, it is cylinder.
2 pi r h, ma'am.
That is a CSA of a cylinder.
2 pi r h plus r, ma'am.
2 pi r into
H
r
plus
plus
r,
h.
ma'am.
2 pi r into r plus h, yeah. 2 pi r into r plus h is the total surface area of a cylinder. Whenever they use the word surface area, it's not given if it is curved or total. So you should always find the total surface area. If it's not mentioned, whether curved or total surface area, you should always find the total surface area. Okay, let me ask you again. What is the curved surface area of a cylinder?
2 pi r h, ma'am.
Total surface area?
2 pi r
2
h,
pi
ma'am.
2 pi r into r plus h. What if I say it is a cylindrical tumbler? What will be the area of the tumbler? And now the tumbler is made of, say, copper. It's a copper tumbler. The tumbler is made of copper. What is the area of copper sheet used? What is the area of copper sheet used to make the tumbler? What for? I just want the expression. I have not given you any numbers. Radius height I have not told you, but what is the expression? Like, will you use 2 pi r h or pi r square
And
h?
2 pi r h plus pi r square.
Correct. 2 pi r h plus pi r square. In the case of a tumbler, it's open at the top. The tumbler is open at the top. So there is no circle or there's no material. Copper is not covered on the top. Copper is found only in the CSA and in the bottom. So CSA is 2 pi r h plus the bottom is a circle pi r square. So 2 pi r h plus pi r square. Yeah. All right. So what you have to do here is, since we have two cylinders, we'll call the radius R1 and R2 and the heights H1 and H2. I'll show you the answer slide so that you can start writing. See your children. Cylinder A, R1 7 by 2 because diameter is 7, radius 7 by 2. H1 is 14. Cylinder B, R2, the radius is 14 by 2, 7 centimeters. Height is 7. So just modify the formula. Pi r square h should be written as pi r1 square h1. Pi r2 square h2. This one is 2 pi r1 into r1 plus h1. 2 pi r2, r2 plus h2. Yeah, please work this. Go through the answer or write a little, read it and understand. Write and then continue writing, read and understand. Do not blindly copy. See how things are cancelled. You should cancel. Don't write 22/7 into 7/2, 7/2, 14 and write 539. You must simplify. 7 and 7 cancels. 2 ones are 2 11s are. Then again 2 ones are 2 sevens are 14. Now 11 into 7, 77. 77 into 9 is 539. Please work all that. Here 7 and 7 cancels and then the product is this. Please work, children. Please work. I'll just get back in 2 minutes. Children, I'm back. Is it over, children? Have you completed writing this?
Yes, ma'am. Yes, ma'am.
Any questions regarding R1, H1, R2, H2?
No, ma'am.
No, ma'am.
And the modification of the formula pi R1 square H1, pi R2 square H2. Is that comfortable?
Yes, ma'am.
Okay.
Yes, ma'am.
R2 is not R square, children. R square is R square. R1 and R2 are just to differentiate between the radii of the two cylinders. R1, R2 does not mean the power. Okay. So see here, the next one. Find the height of a cuboid. Find the height of a cuboid whose base area is 180 centimeters square and volume is 900 centimeter cube. So you've seen a similar question. You can see this and understand. Volume of the cuboid is given. Volume of the cuboid is given 900 centimeter cube. So volume we know is area of the base into height. Area of the base into height. Area of the base is 180. 180 into height is 900. So h is equal to 900 by 180, which is 5 centimeters. Volume is L into B into H. L into B into H is equal to 900. But we know that L into B is area of base into height is equal to 900. Please work this.
Completed, ma'am.
All right.
Completed, ma'am.
Fine.
Completed.
All right. What about Raja?
Completed.
All right. Next one. A cuboid is of dimensions 60 by 54 by 30 centimeters. How many small cubes? How many small cubes with side 6 centimeters? So here the side of the cube is given, not the volume of the cube. How many small cubes with side 6 centimeter can be placed in the given cuboid? It's similar to this one. Similar to this question. This one. There's a go down and there's a room and how many boxes can be stored in the room? There is a room and how many boxes can be stored in that room? So how many boxes? It's the volume of the go down by the volume of one box. Should divide the volumes. The volume of the bigger one by the volume of each small one. And here directly the volume was given to us. Directly the volume was given to us. Similar question. Similar question. See here. So there's a cuboid. So it's a cuboidal box. Dimensions are given to you. How many small cubes with side 6 centimeter can be placed in the given cuboid? So the cuboid is like a room. This box, you know, it's a box. Like you can compare that to a room. And how many small cubes of side 6 centimeters, not volume, side 6 centimeters can be placed inside this cuboid? So number of cubes is equal to volume of the big one, volume of cuboid divided by volume of 1 cube, volume of 1 cube. Volume of the big one, the volume of the cuboid by the volume of 1 cube. So all the values are in centimeter, all are in centimeter, so you don't have to change anything. Number of cubes is equal to volume of cuboid by volume of 1 cube. Volume of cuboid is LBH, centimeter cube, by A cubed, because volume of 1 cube is A cubed. Centimeter cube. Why we have written centimeter cube? All the values are in centimeter. So substitute the values. A cube means A into A into A, 6 into 6 into 6. On simplifying, we get 450. Write down, children. 6 ones are 6 tens are 6 ones are 6 nines are 6 ones are 6 fives are 9 fives are 45. 45 into 10 is 450.
Completed, ma'am.
All right. Okay. Any questions, children? Any doubts?
No, ma'am.
Okay. Find the height of a cylinder whose volume and diameter is given. You can see that the volume is given in meter cubed, but diameter is given in centimeter. So you should change either centimeter to meter or volume which is in meter cube to centimeter cube. Any one. Mostly we change to the smaller unit. So we change meter cube to centimeter cube. Find the height of a cylinder. Find the height of a cylinder whose volume is given and the diameter of the base is given. All right, so we'll first convert the volume. Volume of cylinder is equal to 1.54 meter cube. How do we convert meter to centimeter, children? How do we convert meter to centimeter?
Multiply by 100, ma'am.
We multiply by 100. So meter cubed to centimeter cube, do it 3 times. Into 100, into 100, into 100. Whatever you do it 3 times because meter cubed to centimeter cube. Meter to centimeter multiply by 100. Meter cube to centimeter cube. Do the same action 3 times. So the volume of the cylinder will be 1.54. We are converting meter cube to centimeter cube. So into 100, meter to centimeter into 100. Do it 3 times. Do it 3 times. Then it's converted to centimeter cube. So now these two decimal places and 2 zeros. So it will be 154 followed by 1234 centimeter cube. Now pi r square h is equal to this value. So 22 by 7 into r square. 70 into 70, correct? Because diameter is 140. So radius is 70 into h is equal to 154, 1212. Volume of the cylinder is given, children. We'll convert that to centimeter cubed. See, you can convert. I'll do it both the ways. I don't know how I've done it here. Okay, now here I've converted a centimeter to meter. So let me work this for you. I'll do it again. Same thing. See here, volume of cylinder is given to be 1.54 meter cubed. So that is nothing but 1.54 into 100 into 100 into 100 centimeter cubed, which is 1541212 centimeter cubed on multiplying. So this is nothing but pi r square h. Why? Because volume of cylinder is pi r square h. So 22 by 7 into radius. Diameter is 140. Radius is 70. Radius is 70 centimeters. Volume is also in centimeter cube. So 70 into 70 into h is equal to 1541212. So you can cancel here. 7 ones are 7 tens are. So h is equal to 1541212 zeros divided by 22 into 10 transposing into 70. So h is equal to, I'll just copy the answer from here. It's 1 meter here, so it will be 100 centimeters. 100 centimeter you will get. So h is equal to 1 meter. 100 centimeters, 1 meter. So the height of the cylinder is 1 meter. Please write down this, children. Is it over, children?
Completed, ma'am.
All right. And children, one more thing. Can we have a class tomorrow? Because this Saturday I will not be able to teach. The Saturday. Or can we have it on Friday or tomorrow? Can we have it on Friday from 6 to, just this Friday alone? From 6 to 7:15 like today?
Yes.
Yes, ma'am. Ma'am, can
Yes,
we
yes,
meet
ma'am.
6:30?
Tomorrow I'm having a class, ma'am.
Ma'am,
Okay.
I can join only by 6:30, ma'am, because I'll have Hindi tuition.
On Friday, is it?
Yes, ma'am. I have Hindi tuition every day, ma'am, actually. From Monday to Friday.
All right. Okay. Maybe.
Ma'am, I'm fine if it's 6:30 to 7:30.
Okay, I'll do something, Madhumita. In case you have to miss the first half an hour, I'll help you out later. Supposing I'll try my best because I have a class after that. After your class, I now also. So today now I have a class after yours. So in case I make it from 6 to 7:15 on Friday, I'll help you with the first half an hour later.
Okay, ma'am, no problem.
Yeah, okay.
Ma'am, I'll use the meeting recording, ma'am. I don't have much doubts in this lesson.
Sorry?
Ma'am, I'll use the meeting recording, ma'am. I don't have any doubts in this lesson.
Okay, that's nice. Okay, Madhumita, fine. So children, our next class will be on Friday from 6 to 7:15. I hope I don't forget. In case I forget, just remind me on WhatsApp, children. please, because it's not a regular class. No, sometimes I might just miss it. So Saturday we'll not have the class. We'll have it on Friday. Okay, so coming back to this answer, is it over, children? Have you finished writing this?
Yes, ma'am.
So here we are converting meter cube to centimeter cube, and we're using the radius in centimeter. So everywhere we have centimeter. So height you will get 100 centimeters, which is 1 meter. Here we have the volume in centimeter meter cube, right? So we are converting. We're converting the radius, which is in centimeter, to meter. So this is about the cylinder. So for the cylinder, radius is 70 centimeters. So 70 centimeters means 70 by 100 meters or 0.7 meters. Or you can take the 7 by 10 also. I'll just work this for you. Work it for you, 1 minute. Let's do it together, children. I'm explaining, I can work it and see here. So now again for the cylinder, please write along with me. Okay, so cylinder diameter is equal to 140 centimeters. So radius is equal to 140 by 2, which is 70 centimeters. That is equal to 70 by 100 meters, which is 7 by 10 meters. You can have the 7 by 10 also, children. Don't have to convert it to what is that 0.7. See, everything is fine. You can take a screenshot of this answer also. You can go through this. Take a screenshot. You can have it as 7 by 10 or 0.7. Take a screenshot. You can go through this answer also. You can have it as 7 by 10. So now volume of cylinder is equal to 1.54 meter cube. Pi r square h is equal to now 1.54 meter cube. Okay, so you don't want to have it as a decimal. You can convert it to a fraction like this. Is this understood? We are not converting meter cube to centimeter cube or something. We are getting rid of this decimal point, 154 by 100. So 22 by 7 into radius, which is in meter, 7 by 10 into 7 by 10. It's in meter. Volume is in meter cube, radius is in meter, 7 by 10 meters. Volume is in meter cube. And why 154 by 100? The decimal point, to get rid of the decimal point, into h is what we have to find, is equal to 154 by 100. We can cancel the 7 and 7 here. So h is equal to 154 by 100. What all will go up to the numerator? The two tens will go up to the numerator. And in the denominator, you will have 22 and 7. I hope you understand. The two tens here will go up to the numerator on the other side. And this 22, 7 and 7 will come down to the denominator. Oh, this 7 got cancelled, right? So 22 and 7 will come here in the denominator. So 100, 10 and 10 will get cancelled. 22 into 7 is 154. 22 into 7 is 154. So you will get 1. H is equal to 1 meter. So the height of the cylinder is 1 meter. Understood, children? The rule is, in the equation, all the values must be in the same unit. Centimeter or centimeter square, centimeter cube, like that. If it is meter, meter, meter square, meter cubed. There should not be a value, one value in centimeter and the other one is meter cubed. Yeah. All right, children. All right, children. So that's it for today's session. Thank you so much.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, children. Thank you.